What if you know a triangle's three side lengths, but have no idea what its height is? There's still a way to find its area. No height needed at all. This video covers area for parallelograms, triangles, and circles, ending with that exact trick. A parallelogram's area is base times height. Slide a triangular piece from one end to the other, and it reshapes into a rectangle with the same base and height, so the areas match exactly. A triangle is simply half of that. Take any triangle, make a second congruent copy, and flip and join them to form a parallelogram with the same base and height. So a triangle's area is always half of base times height. One elegant consequence. A median, the line from a vertex to the midpoint of the opposite side, always splits a triangle into two smaller triangles of equal area, even though they're usually different shapes. But what if you only know the three side lengths, A, B, and C, with no height in sight? That's where Heron's formula comes in. First, find the semi-perimeter. S, just half the total perimeter. S corresponds A plus B by C, 2. Then the area is the square root of S times SA times SB times SC. Try it on a 3, 4, 5 triangle, S über 6, so area spora, square root of 6 times 3 times 2 times 1, which is square root of 36, giving exactly 6, matching the half base times height answer perfectly. Brahmagupta extended this same idea to four-sided shapes. If the quadrilateral is cyclic, meaning all four corners sit on one circle, then knowing just its four sides, A, B, C, D, is enough. With semi-perimeter S from A plus B plus C, D, 2, the area is the square root of SA, SB, SC, SD. Notice the family resemblance to Heron's formula. In fact, shrink one side of the quadrilateral down to 0 length, and Brahmagupta's formula collapses exactly into Heron's. That's not a coincidence. It's Heron's formula as a special case. Finally, the circle. Just like circumference divided by diameter is always the same constant pi, the area of a circle also connects to pi. PR squared. One beautiful way to see why: slice a circle into thin, equal pizza slice sectors and rearrange them, alternating tip up and tip down. They interlock into something very close to a rectangle, with height equal to the radius r and base equal to half the circumference, which is PIR multiply base times height, and you get exactly pi r squared. And just like arc length, a sector's area, the pizza slice-shaped region between two radii and an arc, is a fraction of the whole circle's area based on its angle. Area of sector buried PIR squared times theta over 360. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. A triangle with sides 5, 5, 6 has semi-perimeter, S 8. Heron's formula gives area square root of 8 times 3 times 3 times 2, which is square root of 144, so the area is 12. A parallelogram's area is base times height. A triangle is half of that. Heron's formula finds a triangle's area from its sides alone. Brahmagupta's formula extends this to cyclic quadrilaterals, and a circle's area is always pi r squared. Free notes in the description. Subscribe to Clarix for the rest of Class 9 Maths.